Yeah, done. Yeah, started recording. Yes. Guys, I have done relations in the last class. Relations are just only introduction I have given. And why the relation is that, how the relation has been drawn. And first we have taken a set, then we have gone for a Cartesian product. The Cartesian product is nothing but an ordered pair that is related to a point in a coordinate plane, coordinate system. And we defined a relation as subset of A cross A or A cross B. Okay. So relation is a subset of A cross B or A cross A. Relation is a subset of A cross B. This is the definition of a relation of this. Subset, not less than my subset. I hope everybody, yeah, even you can put like this. So we have discussed how many subsets are there in the R and in A class B. Then how many relations are possible? All these things we have seen, right? In the last class. You can see the video, please, if you see, if you want to have a just one small n of A equal to 3 and n of B equal to 2, then n of A cross B equal to what, ma? 6. Right? So next number of subsets on a power set, ma. Power set. So n of P of A equal to 2 cube, ma. Number of subsets. Number of subsets of A is 2 cubed years. In 3 irukala 2 cube. This one number of subsets is 2 square power. This one the number of subsets one the 2 power 6 might. This is how we have built the story for relations here. So if A cross B has got 6 elements, then the number of relations possible, okay, number of relations possible are 2 power 6. That means 64 relations we can make. Okay. Right. So this is what we discussed the other day, and also we discussed about what are the types of relations are there. What are the types of relations are there? I said number 1, a reflexive relation, right? And number 2, symmetric. And number 3, transitive. Right? Okay. So how do we define a reflexive relation? Friends, here, if I take A equal to 1, 2, 3, yes, A is 1, 2, 3, and A cross A, let us take, okay, A cross A. Let's not get 2 sets. So our R is a subset of A cross A. R is a subset of A cross A. Now, to say that a relation R is reflexive, R is reflexive, what we have to tell is, for every A belongs to A, okay, A comma A belongs to R. A comma A belongs to R. That means what? Identical. Both should be identical. The first element and second element should be identical. Such type of relations for every A comma A. That means what? If I take R here, I have to get 1 comma 1, 2 comma 2, 3 comma 3. This is called a reflexive relation. For every A means what? For 1, 2, and 3, you must be right. A comma A, B comma B, C comma C. So this is called reflexive relation. This is the symbol for every A. For every A. This symbol is for every A. You can write for every A belongs to A comma A belongs to R. That such a relation is called reflexive relation. Now coming to symmetric relation, yes. R is called as a symmetric relation if A comma B belongs to R, then if then comes my. A comma B belongs to R, then B comma A also belongs to R. And I wanted to tell yesterday the symmetric relation, please. This is called 2 comma 3. This is called 2 comma 3. If this one in the side, you please take this as a mirror. Now y-axis is a mirror. What are the coordinates of this one? If I put here minus 2 comma, what do you get here? If you reflect on this, reflect on the y-axis, you get minus 3 comma 2 minus 3 comma 2 What is the rule actually? Okay, anyway, minus you forget about the minus now. So you call symmetry of this. That's called symmetry. 3 comma 2 and 2 comma 3. Okay, pa. So as I discussed for reflexive here, same way if A was 1, 2, 3. And what about symmetric relation? R is nothing but 1 comma 2, 2 comma 1. Enough. This itself is enough for me. He didn't say that for every A here. See, this in the condition. If there is A comma B in the relation, there must be B comma A in the relation. So there is a 1 comma 2, 2 comma 1. He didn't say that for every A here. Be watchful here. Okay, very dangerous. Okay, that's all. This is a perfect example for 2. For this, the perfect example for 1 comma 1, 2 comma 2, 3 comma 3. This is R is a reflexive. Beautiful example, now please. I hope it is. Yeah. Guys, next is symmetric one thing. My example. I'll write it here. 1 comma 2 or 2 comma 1. Enough simple example I am giving. Next for transitive 3. What the condition he says that all of us know it. If A comma B and B comma C belongs to R. If A comma B and B comma C belongs to R, then the common B will be cut pannunga. Could say A comma C belongs to R. Such a relation is called a transitive relation. So let me take third one here. R is 1 comma 2 and 2 comma 3, and you should have 1 comma 3 also here. If such things, such a relation is called transitive relation. In the set part, this is there in the relation. This also must be there in the relation. So it is 1 comma 2, 2 comma 3, and 1 comma 3. See, for each one we have given an example. So now let us do the exercise 1.1. Please take it here for a while, just for 2 minutes. Is it clear, boss? Am I clear for you, please?
Yes,
Pavitra? Bhavishna? Yeah, Bhavishna has answered. Bhavishna is left, I think. Okay, right. Pavitra, are you clear? Yeah, okay. There is some network issues. Yes. Dharanya?
Yes.
Okay, Madhu?
Yes, sir.
Great. Siddharth?
Yes, sir.
Thank you. So if you have got this one, if you understood this, then I will go for exercise number 1. You got some 15 questions are there. Very long exercise, theoretical one. Really, it is you need to have patience to do this. Lot of patience. That's why I didn't do the very beginning itself. I didn't do this exercise. Okay, it is so somewhat boring. But anyway, we will make it very interesting. Please come on. 1.1. Each question, it takes time, don't worry, we will take 2 days for this exercise, today and one more class, and then we will go for a functions. I think next is the functions. Yeah, types of functions. Yeah, okay, that also 1.2, then we'll have 1.3 also, I think. Yeah, 1.3. Then 1.4 is also there. Yeah, okay. Is there any reduction in the, any reduction in the syllabus, dears? Anybody knows it? Dharanya, you will be up to date? No. Okay. Let us see 1.1. 1.1. First question. Determine whether each of the following relations are reflexive, symmetric, transitive. Each one, okay? Now, what I do is I do the sum here, and then finally I will say that whether each one is, the relation is whether reflexive or symmetric or transitive or all, okay? And also I forgot to tell you my if R is reflexive, R is symmetric, and R is transitive, all the three are there, then we call R is equivalence relation, equivalence relation. R is called equivalence relation. Please note down this point. If R is reflexive, symmetric, and transitive, then the relation R is equivalence relation. Yes, equivalence relation. Okay. So, friends, here, first question is this one. Let us take this given question like this. 1. But we check whether it is a reflexive, symmetric, or transitive, or all the three, or whatever. Okay. Determine whether each one of the following relations are reflexive, symmetric, and transitive. Number 1. 1. Question number 1. Friends, here relation set A is called 1, 2, 3 up to third 14 years. They are natural numbers. Relation is on set A. Relation is on set A. Defined as R equals to X, R is a set of ordered pairs X, Y such that 3x minus y equal to 0, dears. This relation is in the set builder form. Relation is in the set builder form means what? Rule is given. Roster means what? You should write all possibilities. If you keep on writing them, you will never end it. It will take 1 day to complete the complete relation. Yes, complete roster. Roster means what? You have to write the elements. Here itself there are 14 elements are there. 14 into 14, 196 elements are there in the A cross A, right? Do you remember? Do you understand this? Then, if for this relation, that's called relation. This is actual relation, yes. This is relation between X and Y. This is making this R as relation. Friends, here, if you want to talk about the RST, right? If I want to talk about the reflexive relation, I said that for every A belongs to A comma A must be belongs to R. This is the condition of this. This is the rule. Suppose if I take some X belongs to A, okay? Say some 1 belongs to A, okay? I should not say that. I should not go for this. I have to go in general, but I will tell you the example also, okay, right? When 3x minus y equal to relation is like this, my relation is 3x minus y equal to 0, which implies 3x equal to what, pa? Y. Do you agree, pa? 3x equal to y. That means X comma Y, he is talking about X comma Y, right? R is X comma Y. What is Y, dears? 3X. Please. R is X comma Y, dears. R is X comma Y. Right? Such that X comma Y means what? X comma 3X. X and Y ma. Y is what? 3X. Now, can you say that? See, dears, you can call it is a relation only when first element and second element are subjected to this rule. When I say reflexive solidity X comma X, right? R is X comma X, Y comma Y, something like this, okay? It goes. But if I say X comma X under the, does it belong? Can you say X comma X belongs to R? Can anybody say? X comma 3X belongs to R, dear. Do you agree, ma, please? X comma 3X belongs to R. See, this is what he said. R is X comma Y, such that 3X, Y equals to 3X. So X comma Y and I can write X and 3X ma, belongs to R. Fantastic. But when I talk about the reflexive, the elements must be identical. Elements are identical. But elements are identical means the rule does not obey. It won't obey the rule. What type of elements will be belongs to R? Only this type of elements will be, say, 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 16 is not there. Leave it. Friends, so in the all elements, they belongs to R, ma, please. Please note down, yes. So X comma X under does not belongs to R. Therefore, it is not reflexive. Not reflexive. Do you agree, dears? Do you agree? All of you say yes, ma, please. One yes. Is it clear or not? Pavitra?
No, sir.
Not clear. Madhu? யாரோ ஒருத்தர் சொல்லுங்கம்மா, please. Is it clear or not னு கேக்குறாங்க. Somebody said no. Who said? Dharanya or Arpit has joined. Bhavishna has left, I think. Okay, fine. Is it clear or not, ma? Yaar clear avula sollunga, please. I will tell it. Once again, I will teach. You got it. Okay. Dharanya, clear? Pavitra? Madhu? Is it clear, ma? Right. Okay. Arpit, is it clear?
Just till the last, sir. I mean, I understand what we're trying to do, but I don't get. I mean, could you just go over the process one more time?
Yeah. See this, friends. Here, this is the set here. R is the relation defined like this now, please. R is the relation defined like this. What is that? R is the set of ordered pairs such that 3x minus y equal to 0. That means what? The x and y elements must be related like this. X and y elements must be related like this. Then we call it a relation. Friends, here 3x minus y equals to 0 means what is 3x ma? 3x equal to y, right? So R is x comma y, he said, right? Under this condition. Shall I implement that condition ma? X, but what is y? 3x. So x comma 3x is 1 comma 3 belongs to R. 2 comma 6 belongs to R. 3 comma 9 belongs to R. I can write many. That's of course this much. Is it clear? Then I can write.
Yes, sir.
Is it okay? So far is okay? Now friends, but what is reflexive relation? Reflexive means what? Identical elements. If I take X as the first element, second element is also X. But do they follow this relation? Are they equal? No.
No, sir.
But they are equal. That means does not belongs to R. Puriyadaippa?
Yes, sir.
Yes, sir.
Therefore, R is not reflexive. R is not reflexive. Clear, ma? Right. Next one is symmetric part. Symmetric one, the general definition of if A comma B belongs to R, you can take A comma B, X comma Y also you can take, okay? Right. Doesn't matter. If X comma Y belongs to R, Y comma X must also belongs to RDS, okay? Right. This is what is the general definition of our symmetric relation. But as per the relation here, first element and second element are related like this now. Okay, X comma 3X belongs to R. Let us say, assume that it is there, okay? Okay. Now reverse it, you get. Can you tell me now, please? Can you tell me 3X comma X belongs to R or does not belongs to R? Anybody, please? Is it true?
Yes, sir.
I wrote it. Yeah. Is it correct or wrong?
Yes, sir.
Yes, sir.
No. No, is it correct or wrong? And Kekla, I wrote like this. X comma 3X belongs to this because 3X minus Y is 0, Y is 3X. But can you say, what is the rule here? The rule is first element should be, means second element should be 3 times the first element. Now can you say here?
No, sir.
No, does not belongs to R. Therefore, it's not symmetric. Please follow this. You should think like this, mass. Second element is 3 times the first element. That's the story. That's the relation, please. Three times first element. Fine. Adi, see this. Here actually first element is 3 times the second element, which is not a relation. The relation is, this is what the relation is. Second element is 3 times the first one. In an ordered pair, second element should be 3 times the first element. It is the relation, please. That you follow every time, please. Inga, second element is not 3 times the first element. Not a relation. It's not a relation is not a reflexive relation. Let us look at second one. X comma 3X belongs to R. Then 3X comma X must also belongs to R to say that it is a symmetric relation. But here, second element is not 3 times the first element, whereas reverse is there. Okay. Therefore, it is not belongs to. Therefore, it's not a symmetric relation. Note panikonna, please. There is a note panikonna. This is the general definition. Okay. If this is taken, this is given. If you can then, if you can say this Y comma X also belongs to R. If you can say that second element is 3 times the first element, then it is a pakka relation is sanctioned. But here, Parina, please. First element, second element. Let us say if this is given now. Then 3X comma X, here second element is not 3 times the first element. Hence, it is not symmetric. Do you agree with me, dear? Tell me. Do you follow?
Yes, sir.
Yes. So it is not symmetric, yes. Somebody wants to say something, I'm not able to say. Next, third one, ma, transitive relation. Note panikoma, this styles will be different, okay? Each one will be doing differently. 3x equal to y. Here, 1, 3, 2, 6, 3, 9. These are the elements which should be there in the, these are the ordered pairs which must be there in the relation matrix. Second element is 3 times the first element. Obey our, it is not a relation. Come on. Now, the third one is called a transitive relation. Transitive is defined by every time you do follow this procedure. The biggest problem is the procedure. Okay? What is the procedure for transitive relation? If A, comma B or X, comma Y, let us follow that only. Okay, X, comma Y belong X, comma Y and Y, comma Z belongs to R. Right. Then what? X, comma Z must belongs to R. In the rendu satisfy idi kandipa satisfy aganam. Okay. If it is a relation, if it is a transitive relation, if it is a transitive relation, if these two are given, then automatically this will be belongs to R if it has got the quality of transitiveness. Okay. So friends, here I will tell you now. Let us take this one. X, comma Y, X, comma 3x belongs to R. Y is 3x ma. Y is 3x. Z also, right? Because it belongs to R. Means what? It is 3 times. Okay? That means what? This is called 9x. Pakka belongs to R. We need not worry, right? I am taking this. If I take this, now please tell me the remaining 2 elements. Then you tell me x, comma 9x. Can you say belongs to R or does not belong to R? Solunga, please.
It does not belong.
Exactly. Why? Second element should be 3 times the first element. That is our relation. That's our relation. But here, first element is, second element is 9 times extra. Okay? Puridama, everybody is able to get it, ma? Please tell me. Pavitra, clear?
Yes, sir.
Right. Right. Yeah. Everyone got it, ma, please? So please take it, ma, please. So you can say now it's not a transitive relation, ma. Therefore, the first sum, which is neither reflexive nor symmetric and nor transitive. Yes. So this is how we can solve the questions. In the system definition on the correct and the relation on the correct mathematics, mathematical questions. Some are general relations are also given, like father, mother, sister, brother, and all. Those are also we can put into whether reflexive, symmetric, and transitive. So kindly take this properly. You see, first line what I am writing is I am just defining the transitiveness mark. Are you okay? That's a common thing you can write. You cannot change, I cannot change, right? You write it. Then you follow this relation. See, we said that first element, second element is 3 times first element. So x, comma y, x, comma 3x. Y is what? 3x. Z is what? 9x, because I said it belongs to R. Now you have to check this you have to check it now. X. Z is what, my 9x. Is it 3 times? Second element is it 3? Is it 3 times? Is second element 3 times first? This is a question you should ask. If it is yes, you say belongs to. If it is not, no, it doesn't belongs to. What a brilliant question. How, it's a very simple only, but in English, in the terminology, in the text format, it is going to be disturbing you. I know that. Okay, definitely it's going to disturb you. So, I hope all of you understood the format also, please. First, you define the general definition of each relation. Then you take the actual relation given here, implement that relation for each relation. If it follows the given relation, if it follows the general definition, you can say yes, it is that relation. Otherwise, no. That's all. That's all. Every story is like that only. You can talk about the second one also. Third one. Any question, please. Say 1 to 5 more. 1 to 4 first. The second part, right? You try the second one, please. Second one. Once again, whether we put that format in order or not, let us see, please. Relation R in the set n of natural numbers defined as R is given as x comma y such that y is x plus 5. Y is x plus 5 and x is less than 4. X is less than 4. And R is set of natural numbers. R is on n. N means what? Natural numbers. Relation is on n. Natural numbers. Okay. Now we have to see whether the relation is given as is it a reflexive, symmetric, and transitive. Report in or tick cancel cross, right? Let us take yes. First one is that see for y is x plus 5 mark. That means what? X and x plus 5, these are the two elements of the relation matrix. That means what? Second element is 5 more than first element. Yes. Do you understand this, ma? So first you define like this, ma, so that you can easily put into words. Then you can easily write transitive, ma. Transitive. A. Reflexive, please. Reflexive. We know that for every A comma A belongs to R. For every A belongs to A comma A must be belongs to R. He is telling in the relation second element is 5 more than the first element. But you want like this. The relation reflexive is asking, I want both identical elements. So how is it possible, ma? See, if I write A comma A, they both are equal, right? Reflexive demands they both must be equal. But relation is asking second element is 5 more than the first element. So here A and A are equal, but first element is equal to second element. But relation is what, ma? Second element is 5 more than first element. Hence, x comma, okay, first element is A, second element x comma x report, ma. X comma x. So we know that first element is to be reflexive relation, it should be x comma x plus 5 belongs to R. Right? This is what is given. And this is what is defined, ma. In the model, where ma? Reflexive agadi. Chance kadiyadu. Why? Given is what? X and x plus 5 belongs to R. But here, he is asking x comma x belongs to R. It's not possible. Therefore, R is not reflexive. Let us go for B. Symmetric. We know that if x comma y belongs to R, then y comma x also belongs to R. This is what this fellow wants. A symmetric fellow wants. But general relation he has defined like this. Okay, x comma y and x comma x plus 5 belongs to R because this we have to give a chance. But in the second attempt, x plus 5 comma 5, will it be belongs to R? Pavitra, tell me. Is it belongs to R, does not belongs to R mind? Anybody? Anyone, please tell me. Faster. Is it belongs or yes, pa? One of you tell, yeah. Somebody can tell, right? Is it belongs or does not belong? So, minute, please. Pavitra, Siddharth, Siddharth, is it belongs or come on? What is this?
Sir, have you written x plus 5 comma 5 over there, sir? Or is it x?
X. Sorry. Yeah. X plus reverse, then reverse panel, right? X comma y comma x. X plus 5 comma x. Is it belongs to R, does not belongs to R?
No, sir.
No. Thank you. Thank you. Therefore, not a symmetric, no, please. In the following, okay? In the following, x comma y comma x. So, if x plus 5 x is second element is 5 more than the first element, second element is x, is a 5 less than this, right? Okay, but we want second element is 5 more than 1. So that's why it's not symmetric, yes, okay? Third C, transitive. If x comma y belongs to R, not only x comma y, both x comma y and y comma x, y comma z, right? This is given ma. This one you can take it for granted. Then this one we prove panna. You got x comma z belongs to R. This is the transitive demands. Okay. But our relation is given like this ma. X comma y. That means what? X and x plus 5. You give it ma. Y. Y means what? X plus 5. Second element should be 5 more than. Sir, sir, grant this is given ma. Given. Either R belongs to R. That means what? What should be the second Z ma, please? Anybody?
X plus 10.
Brilliant. X plus 10 belongs to R. Then X comma Z ma. X comma Z. X comma Z ma. What is that X comma Z ma? X is X only. Z is X plus 10. Can you say second element is 5 more than, precisely 5 more than first?
No, sir.
No. Therefore, does not belongs to R. Yes. Is it clear, ma? Now it's not transitive. Yes. This is how we can handle these questions. Yes. Is it clear, ma? Now?
Yes, sir.
Yes, sir.
Please take it. Yes. Please take it.
Sir, I have a question, sir.
Yes, sir.
So, what is the use of knowing reflexive if this is all turning out wrong like this?
Okay, very good. Okay, good question. See, you can't say precisely what is the application of this. Okay. Actually, what is the story? See, first is sets is there. Okay. Set. Sets is connected to relations. Relation is connected to function. So this is how this precisely, see, there is nothing like, there's nothing here without applications. You will, because you take everything wholesome, then we will see that how they are exactly related. We can't, stand alone, you can't say that what is the use of it. But this, first of all, you understand this. They made it such a brilliantly, this effort and given to us. To understand this, we are struggling for it. Okay. Yes, absolutely. There is nothing like in mathematics which is not. I too used to think like this, but you can't find it for a real time. Everything I want to use outside another mudiyadu. Okay, just like Android phone மாதிரி நம்ம use பண்ண முடியாது. Okay, so it's a, all these things are developed because of this mathematics only, no doubt in that. I'll tell you. But precisely, your question is good. Yenna sir, what is the purpose of this one, using this one? Definitely there will be a big purpose and big usage will be there. We will come to know when we have a application type questions. Okay, right. I too will think and tell you on that. So shall I go for next one, dears?
Yes, sir.
That's all, man. The relation catch பண்ணுங்க. What the relation says என்றது நீங்க express பண்ணுங்க. Okay, he express it like second element is, second component or y coordinate is 5 more than x coordinate என்றது நீங்க அதை define பண்ணுங்க. Okay, ப்ராப்பரா இப்போ வந்து C D, whatever two relations we have taken, they are not all relations, right? They are not all belong, neither they are neither reflexive nor symmetric nor transitive. But let us take one relation. Maybe look at fourth one, dear. Fourth one. Third one is also fine. Third one பண்ணலாம். இதுக்கான thirdல வந்து here first and second are all are not. Okay. First second வந்து all of them are RSTR neither. Okay. But third one கொஞ்சம் வித்தியாசமா இருக்கு பாருங்க. Let's see third one. What we are in the first question. Yes, we are in the very first question, please. A is given as 1, 2, 3, 4, 5, 6 mark. Third one, yes. A is given as 1, 2, 3, 4, 5, 6. Relation R is defined on this set mark. R is on set A. Okay. R is on set A. Okay. And how the relation R is defined? R is defined as x comma y such that y is divisible by x. Wow. Y is divisible by x. That is what second element is divisible by first element. Parma, if I want first element, means second element is divisible by, I can write 1, 1, fantastic, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Yes or not? Yes. So just making it understand. You have to catch that through numericals you understand better. Y is divisible by x mark. Suppose if I take now reflexive, for every A belongs to A comma A must belongs to R. Or for every X belongs to A, X comma X belongs to R. This is the reflexive relation mark. Is it right? Now please tell me, second element is divisible by first element mark. Is it second element by first element? Is it divisible or not, ma? X by X is 1, fantastic. Therefore, so X comma X belongs to RBS. Okay, X is divisible by X. X is divisible by x. Therefore, x comma x also belongs to R. Okay, clear, ma? X is divisible by x. Therefore, x comma x belongs to R. Is it clear, ma? Clear?
Yes, sir.
So it's a reflexive is done, ma. Symmetric and transitive quadra, like V. If x comma y belongs to, if x comma y belongs to R, then y comma x belongs to R. Please tell me yes. In this is belongs to R, ma. Already you have to see. This is you have to verify it, ma. This you need to verify. This is given DS. Okay. If and anapa, if means what yes? If and given DS. Note down this one, please. If and given. That means if this is given to you, is it true or not? Now it is given that y is divisible by x. Given. What is given? Y is divisible by x because it belongs to R. You need to verify here. Divisible by x. Now can you say that x is divisible by y, ma? Can you say that x is divisible by y, ma? Yes. Do you agree or not? Tell me, please. If you are going to answer it. Is it true or false?
Yes, sir.
1 comma.
True.
Yeah. Is it true or false? Tell me.
True, sir.
Can you say that x is divisible by y? That means
Yes.
1 comma 2 belongs to R. Can you say 2 comma 1 belongs to R? Is it true or false? Siddharth, are you there in the class? Can you say 2 comma 1 belongs to R? One of you say yes or no, yeah? 1 comma 2 or not, 2 is divisible by 1. Can you say 1 is divisible by 2 and K? I'm asking a question.
No, sir.
No, it is not this. So, no, right? That means not transitive, not symmetric. புரியுதாப்பா சொல்றது புரியுதா? Pavitra, is it clear? புரியல, if it is, I don't know what's going on. Right. C part, now C part. What is C transitive, please? X comma y belongs to x comma y and y comma z belongs to R. Then x comma z belongs to R. This is given to you and this you have to verify now. Please understand this. I don't think you can get such a simple way anywhere. I can tell you one thing. Friends, x comma y and y comma z belongs to R. What he said, here is y is divisible by x mark. Here is y. What do you mean by x comma y belongs to R? Yes, x comma y belongs to R means what? Y is 3k. Y is divisible by x. K x. This is called what? My x comma y belongs to R means, which implies what? Y equal to xkx. Yes or no? Last year we had a mathematical reduction, please. Similarly, y comma z belongs to R means what does it mean, ma? Is z is divisible by y? Is z equal to some ly? Yes. Yes or no? Now verify. This is given to you. Now verify. What to verify, yes? X comma z belongs to R. X comma z you take first. What is X Meyer? X only you write it. Okay. Can you say that Z, what is Z ma? Z is what now? Ly, right? Z is Ly, use panala. X, L, Y is what ma? Y is Kx. So second element is X comma Lkx. Can you say that second element is divisible by first element? True or false?
True, sir.
True. That's all. So this is second element, ma. The first element. So you see that Lkx by x, ma. Yes, perfect. Divisible, ma. Therefore, it is transitive. Yes. Is it clear, pa, please?
Yes, sir.
All of you, Madhumita,
Yes, sir.
are you clear? Huh? Done. Done. Pavitra, you don't have. Yeah, her mic is terrible, Mama. Maybe network issue or what? Yeah. Okay. Please follow this one. First, second one, the RSTR neither. Third one, it's not symmetric, but it is reflexive and transitive. Like this, see, I am putting effort to make you understand, okay? Once you start thinking like this, I think no question will be difficult, except somewhere, very tricky questions will be there, that we will attend to that. But you start practicing like this, follow like this. I hope now, are you getting some sense, Arpit? Are you getting some sense about the relations now?
Yes, sir.
See, this is a really beautiful one. Second element is divisible by first element. Second element is y is divisible by x. Second element is divisible by first element. Second by first.
Sir, K is a constant or L is a constant, right, sir?
Absolutely, absolutely. See here, y is divisible by x ma. 6 is divisible by 2 pa. Is it right? 6 equal to 3 into 2. So 3 is x. Now whatever that foreign number k. Yeah. What you said is right, okay? So K and L are positive integers. Why? Because we have taken only positive integers. You all understood, ma?
Sir, in reflexive, sir, if the two elements are of opposite sign, is that true or is that false, sir?
Can you tell once again?
If we want to verify reflexive, and if two elements are opposite signs, like one is positive and one is negative, but they're the same value, then is that
No,
reflexive or not?
it's not reflexive. They are not, see, what do you mean by identical here? Tell me. Identical means there is no difference at all. Absolutely, they must be same. How can you say minus 2 and 2 they are equal?
Right, sir.
That's it. They must be equal. Minus 2 and 2 they are not equal. That's it. Okay, clear? Have you taken DS? Have you taken first one, second one, third one? All the three relations. First you define it. This is reflexive definition now. This is symmetrical definition. This is our transitive definition now. Then we are implementing. This is given DS. This is given. Given means what? They follow the rule. X comma y belongs to R means what? Second element is divisible by first element. And because they belongs to R, இது வந்து கொடுத்திருக்காங்க. இது வந்து நம்ம verify பண்ணோம், please. So in the concept நீங்க புரிஞ்சதுன்னா, I think you will start working on this. It's not a big deal more. Yes, similarly, you can do the fourth one. Now you please tell me one by one. I will ask, I don't do it. R is on Z, R is R in the set Z of all integers. Z means what? All integers. Defined as R is defined as X comma Y. R is a set of ordered pairs such that X minus Y is an integer. Follow this. Friends, ஒருவேளை X minus Y is a natural number, whole number னு சொல்றீங்களா? Next question, okay? X minus Y belongs to whole number. Here X minus Y belongs to Z னு கொடுத்திருக்காங்க. This. See, what do you mean by integer? It could be positive, it could be negative, it could be zero, but it's not a fraction. So friends, here, as per the reflexive, right? For every X belongs to A means what here, ma? A belongs to Z. X belongs to A. Set A, ma, set A. And X comma X belongs to R. Now tell me, what the rule says that first element minus second element must be integer. X minus X equal to 0. 0 belongs to Z. Verified, ma. Therefore, friends, here R S T. R is Paka. Clear, ma?
Yes, sir.
You have to verify this, ma. X minus Y is an integer and verify. Okay. So here the rule is X comma X belongs to R. Okay. If I take X minus X is 0, Paka integer. Okay. So B, if X comma Y belongs to R, then Y comma X also belongs to R. Yes. Okay. X minus Y is an integer. X minus Y is an integer. No doubt, because it's a given. X minus Y is an integer. So this belongs to R. It means what? Given. X minus Y belongs to Z. Given, right? Can you say Y minus X is also an integer, please?
Yes, sir.
Wonderful. Wonderful. Y minus X is also integer. Therefore, the second also verified, verified. Therefore, it is symmetric. Symmetric also true. Now, third formula, third is what? If X comma Y belongs to X comma Y and Y comma Z belongs to R, then X comma Z belongs to R. This we have to verify it now. What is X minus Y belongs to Z? Y minus Z also belongs to Z. Okay. Also belongs to Z. Now, can you tell me X minus Z, ma? X minus Z, is it an integer or not, ma? X and X, Y, Z are integers, ma. X, Y, Z are integers. It is defined on Z. So, an integer minus integer, is it integer or not? Therefore, it is equivalence relation, because all the three are correct. Is it clear, ma?
Yes, sir.
Done. Take it, ma. Take it just for a minute. I'm spending a lot of time on first few questions. Why? Because there's no point in moving forward. சும்மா ஏதோ எழுதிட்டு போர்டு மேல எழுதி எது தெரியாம நீங்க காப்பி பண்றது நான் சொல்றது அதெல்லாம் எனக்கு பிடிக்காது. Please, okay, let us go slowly, understand it. Once you understand, I think you can do by yourself. எல்லாமே எல்லா கொஸ்டின் இதான் பண்ணப்பா. Yeah, repeat, okay? Okay, but fifth one, fifthல வந்து 4 கொஸ்டின் 5 கொஸ்டின் இருக்கு பாருங்க, 5 கொஸ்டின் இருக்கு பாருங்க. Fifth. Here, R is on a set of human beings. First time he is coming out to R is on the set of R is on set A. R is on set A. A is called what? Set of human beings. Done. In a town. Okay, but in a town. At a particular time given by A, okay? R is X comma Y. Order pairs of that X and Y. This is the relation, my X and Y work or at the same place. Okay, yes. First, when I talk about two identical persons, two identical persons means what? Only one person, please. Yes or no?
Yes, sir.
So, X and X, the X is working, X and X are working in the same place or not? Yes or no?
Yes, sir.
Reflexive means what? Identical. They are identical. There is only one person, correct? When I talk about there are no two identical persons in the universe. Please understand this. But X and there's only one person. These two are not different persons. There's only one person. When you talk about one person, they both are working at the same place or not? Okay? There are nothing like two here, only one. So that person is working over there. Okay? Let us see second one now. B. If X and Y belongs to R, can you say Y and X belongs to R now, please? Yeah, can you say this? Yes. This is Pakkama. They have given it. X and Y are living in the same place, working in the same place, working in the same place. Can you say Y and X are also working in the same place? Say all of you, simple one.
Yes, sir.
That's it. Belongs to R. If X and Y are working in the same place, definitely Y and X are also working in the same place. Therefore, first one is reflexive, symmetric, transitive. Both are true. Let us check the schema. Now, X and Y belongs to R. X and Y and Z belongs to R. Means what? X and Y are working in Virudhachalam. Let us take, okay? Y is working in Virudhachalam means what? Y and Z are also working in VDM, right? That means what? X, Y, Z, all of them are working in Virudhachalam. Can you say that now? If, okay, this is if, then X comma Z. Please tell me, it should be belongs to R. Can you say X and Z are also working in the same place?
Yes, sir.
X, Y, Z are working in VDM, right? Now, what is there here? Question is, does X and Z live in Virudhachalam or not? Yes. Yes or no? That's all. That's all. Is it clear, Mark?
Yes, sir.
So that's the first one, Paul. Like that, you can do the second one. Second one, X and Y live in the same locality. X and Y, sorry. Yeah, X and Y live in the same locality. So same locality and same place, both are Same. Therefore, the second also, first one is this, second one is also same part. Live in the work at the same place is as good as live in the same locality. Therefore, second also we have done. Fifth one the second. That's called B. A B. A is done. B is done. Next C. What is C, dears? X is exactly 7 centimeter taller than Y. Array, X is exactly 7 centimeter taller than Y. Now, okay, can you say two identical persons? Can you say one person is two identical persons? Can you say one is taller than the other? Yes or no? Here, two identical persons will have the same height. X and X will have same height. Therefore, X is exactly 7 taller than Y is not followed here. Therefore, it is not reflexive. Next one now, one is done. Okay. Second, X comma Y belongs to R. Now then Y comma X belongs to R. This is the general definition of symmetric. Now you say that X comma Y means what? X is 7 centimeter taller than Y. X is 7 centimeter taller than Y ma. X equal to Y plus 7 ma. That means this is given as Y plus 7 comma Y. This belongs to R. This is if ma. Okay. Now can you say that here is the first element. Okay. First element is what ma? Y. Okay. Write Y as it is. X is what here? X is Y plus 7. Now, can you say that first element is 7 centimeter more than second?
No, sir.
Can you say first is taller than second? Is first is taller than second? Answer it, yes or no.
No, sir.
No, does not belongs to RBS. Therefore, symmetry is also failed. Third one, yes, same story, follow it, ma. XY belongs to R. XY and YZ belongs to R. And X, can you say that XZ belongs to R then? So, first one is Y plus 7, comma Y. Y is Y. Z should be what? Second element should be 7 centimeters smaller than the first one. That means this becomes Y minus 7, correct? They both belongs to R. Now you cancel this and you take these two, Y plus 7 and Y minus 7. Can you say that first one is exactly 7 centimeter taller than second? The difference is here 7. Can you say difference is 7? No. Difference is 14. Difference should be 7 ma. Difference is 7. Here difference is 14 years. Therefore does not belongs to R. Therefore transitive is also very, very, very beautiful, right? So like that you can try more, okay? I hope people are dropping. I think we will stop it here. C and D are there, ma. Last D and E are there. D and E are also like this, ma, please. Both are like this, ma. Okay, this is called D and this is called E. So like this, you can try, ma. Next class we will see, right? You try it by yourself. I hope now you all understand a bit about the relations. Eppadi handle pandradhu. I hope, is it better, Dharanya, now?
Yes, sir.
Sure. Pavitra? Siddharth? Yeah, Pavitra, tell me.
Yes, I understand.
Yeah, you are able to follow, right? Wonderful, right? Siddharth? Siddharth வந்து எங்கோ இருக்காங்க கிளாஸ்ல இல்ல. Siddharth? Okay, right. Arpit, are you clear, ma? Are you better now?
Yes, sir.
Sure?
Yes, sir.
Right. Okay, yes, you continue with the other sums. You try it, okay? You try it. I will, if you have a doubts, ma, please ask me. I will tell you. Anyway, we spend time on this particular exercise and even functions also, these notorious topics. So we have to be slow in this. Okay. I hope I have given you that. See, first class we have given the sets. Then we came to Cartesian product. Then we came to how many subsets are there in the Cartesian product, and R is a subset of A cross A infinity. We came to relations. Okay. Now relations we started. What type of relations are there? What are the three types of relations are there? If a relation is all the three, then we call it as equivalence relation. We started working on the questions in the first exercise. We have done only one question today, whole class. Okay. But anyway, I think I understood really much. I am telling you, I have really understood. I lived with this. I think so. You also have got fair idea about tackle பண்றது. You will start working. You just start working. You take a question, please. Start working. It is difficult, no doubt. But you keep working, you will definitely get only that. How to start, the style you should have it, format you should develop more. That's nothing else. Okay. Right. Thank you very much. Yes. See you in the next class now.